Hello, good afternoon. So I have here an activity for you. We have a star delta control for three-phase induction motor, and we have the Arduino Nano, and we have the contactor equivalent blocks that we have made, and we have a three-phase motor, and we have a transformer, so that we could simulate the motor here, because our motor doesn't have a 6 leads out, so we will be using transformer, so the effect will be the same. And then we have a single push button here to program it with difficulty. Say for example, we have to push 2 times, or to press the button 2 times, and the motor will start up and it will perform Wye-Delta. And then if we want to terminate the operation, we have to press 3 times, say for example like that. Okay, and the LEDs here, this red one will indicate that the motor is off, and main contactor D2, Y contactor D3, and delta contactor D4. Okay, but if we will start it, let us do the light sequence such as this. If M1 and star contactor is energized, there will be 2 LEDs energized, and we will not turn off the D3. If the delta contactor will be started, there will be 3 lights in all. Okay, to indicate that the sequence is already finished, to start the motor in Y and to finish it in delta. Okay, so we'll be having a program for this Arduino Nano. We'll use another diagram for this. Okay, now our software is open, and I will use counter, because remember that you have to press it twice and to press it again thrice in order to stop it. Okay, so I will use a counter here. Okay, put it here. So this one is C0, first counter, and the preset value is 2. Okay, because you have to press it twice. Okay, so I will have to delete this first, and I will put the input 0.2, because according to the circuit, it is connected to a 0 of the Arduino Nano. Okay, so I will put here input 0.2, but this time I will using this rising edge. Okay, so to detect actually the rising edge of the voltage that will be processed to our Arduino. So it would be the errors will be eliminated. Okay, so I will put here input 0.2. Okay, to ensure that the process or the counter will detect only the rising edge of the signal being inputted to our Arduino Nano. Okay, and then if say if we press it thrice with this counter, still the counter will accumulated value will still be increased, so we have to prevent that after pressing it too. Okay, so we will put a contact here, okay, that it should prevent that when the counter will reach its preset value. So this is counter 0, this is counter done. Okay, so if the counter done, if the CTU 0, if the counter 0 here will reach the preset value, so this will be high, so this will become false. Okay, so if it is false, then you cannot press this anymore. That would be recorded by counter 0. Okay, so after the counter 0 had reached its preset value, okay, so we'll put here, we will use a B00. or the buffer or the memory. Okay, and then we'll put here a counter 0 done bit. Okay, so if this counter 0 will reach 2, then B00 will be turned on. Okay, and then after the B00 will be turned on, we will have to create now the program how to stop the operation of the motor. Okay, so I will have to put another counter again here, and this time it is C1. Okay, C1, and then the preset value will be 3. Okay, as specified by our program or problem. Okay, and then we will be using again the input that we have used above. Okay, so this is now input 0, 2, and then this will effect only if the counter 0 has done counting. Okay, so I will put it here. This time it will be 0 counter 0 done. Okay, so say for example, if this counter 0 is not yet done, this counter 1 will not be started. Okay, so it will wait further for C0 to be done. Okay, so how about to reset this? Okay, so it will be turned off if this counter 1 will reach 3 counts. Okay, will reach 3 counts. Okay, so I will put here still, okay, input 0.2, because I will press it, and at the same time it will be a self reset, provided that the C1 will be done counting. So this is C1 done. Okay, C1 done. Okay, and same thing will happen at the above. We have to reset it. So still this is input 0.2, and we have also C1 done. Okay, C1 done. If C1 is done, then it would be reset. Okay, C1 done. Okay, that's it. That is for switching on and switching off. Okay, so if B0 now, you go back now to B0, because this time the motor will be started because you have pressed the counter, you have pressed the input 0.2 2 times, then the motor is expected to start. Okay, so the timer will start now. Okay, timer will start. Say for example, this is T0. Okay, and the preset value will be 5 seconds. Okay, and then this will be triggered by B0. Okay, by B0. Okay, so the timer now will start to count, and then when the timer is done, this will trigger B01. Okay, and then this will be your T0 done. Okay, that would be your T0 done. Okay, so we'll go now to the loads. Remember that we have to use first the buffer or the memory before turning on the load, because if you have a long program, it is really difficult to modify it if your loads are not separated. So we will keep the loads away. For our logics here, we will have to separate it on the last part of our program. Okay, so we'll start on output 0.0. Output 0.0 will be your M1. Okay, that will be your output 0.0, and then we'll add here output 0.1. Okay, output 0.1 will be your delta contactor. Okay, and output 0.2 will be your Y contactor. Okay, and then output 0.3, remember, it is your stop light. Okay, output 0.4, it will be your M1 light, output 4. Okay, and then output 5 will be your delta contactors light, and output 6 will be your this is your Y contactors light, and output 6 will be your delta contactors light. Okay, so we have B00 here. Okay, because when B00 is started, your M1, okay, will be started also, and together, okay, together your output 0.2 will be triggered. Okay, that is your process of Wye-Delta starting. Okay, B00, okay, B00. Okay, that's it. And then your delta will be triggered by B01. This is your B01. Okay, whenever your time, the time has reached its preset value of 5 seconds, but at the same time, the Y contactor will be turned off. So this will be your B01. Okay, so this will turn off your Y contactor. So this is your stop light. So this will be turned off whenever your B00 will be triggered. So if B00 is off, your stop light will be turned on. Okay? Okay, so we have B00 to turn on your M light. Okay, this is your B00 to turn on your M light. Okay, and for your, also for the Y light. Okay, this is your still your B00, and lastly your delta will be turned on by B01. Okay, so this will be all our whole program, and you have to generate it, your whole program, generate this, but this time you have to try the Arduino Nano. Okay, and you have to generate this. Okay, so generate, and we have to export to your circuit there, and let us try this program on our Proteus. Okay, program is loaded. So the program is loaded. Let us see here, properties. We have already the program loaded. Okay, so I've named it to test1. Okay, and exported. You know how to export it already. Okay, and we'll have to start it. We have to start it. Okay, so again, 1, 2 starting, and then 1, 2, 3 stop. Okay, so we'll have to check again. 1, 2 started. Okay, 1, 2, 3 stop. Okay, so we will now check the operation of the Wye-Delta. So again, the motor is still rotating because of the inertia, but the current here is already 0. Okay, so again we have to start it. Okay, so the red light is being turned on. Okay, because B0, remember B0 is not yet energized, and therefore also M contactor and the Y contactor is not yet turned on. So C for the relay. Okay, so the relays are turned off. Relays are turned off. Okay, so we have to start the process. Okay, so 1, 2. Okay, so turned on. So much the current. We have the high inrush current of 60.14. We have to start it again because the operation is a bit delayed. Okay, so we have the full load of 11.7 amperes. Okay, so again 1, 2, 3. Okay, and then it is stopped, and then we have to turn it again. 1, 2. Okay, so the inrush current now is 28 something. You have seen that, and then the current starting is only 6.70, and then now it's turned to delta. All are being lit, and now the full load is 11.7 amperes. Okay, so take note that we have changed the sequence of lights. We did not turn off the Y light, which is D3. Okay, because it depends upon your program. This is our plan, that we have to turn on all 3 lights. Okay, so again you have to press the stop. Have to stop it by pressing 3 times. 1, 2, 3. Okay, okay, and then start again. 1, 2. Okay, so now that is your starting current. Now it's being dropped because it started on Y contactor, and then after 5 seconds it will go to 11.7. that is now connected in delta, and the motor is rotating 1810 rpm. Okay, and the 3 lights are being lit. Okay, once more, stop. Okay, so red light. Okay, 1, 2, that is M1 and star. Okay, 5 seconds, then delta. Okay, so that is our program, and you have to try this also by yourself. Okay, so thank you. Study well.